Hi everyone. Today we have Codeforces around 739. It's a div 3, so it's unrated for me. There's not much else to say. So if you're competing, good luck, have fun. Let's see. Just waiting for contest to start. There we go. Alright, problem A. You don't like integers that are divisible by 3 or end with a digit 3. Output the kth element of a sequence. We can just brute force them, right? Yeah. So it's just... So it's in k, the kth number in the sequence. So for int x is equal to 1, x less than 2000, x plus plus. If x mod 3 is equal to 0 or x mod 10 is equal to 3, then we continue, otherwise it's n minus minus if n is equal to 0. Alright, let's check out problem B, C, D, E, and then F has subtasks. Some number of people have stood in a circle. A person stands in a circle. The people stand evenly. They're numbered clockwise starting from position 1. Okay. You don't know the exact number of people standing in a circle, but it's definitely even. It is known the person with number A is looking at the person number B and vice versa. What is the number associated with person being looked at by person number C? If for specified A and B, no circle exists. Wait, we know that the person number A is looking at the person number B. What is a number associated with person looking at by the people? If for specified A and B. The number of people, we know it has to be an odd number of people, so 1, 2, 3, 4, it has to be like 2 and 4 or 2 and 5. Okay, I see. Like, well, if 2 and 3 are looking at the same person, that means we know 1 and 2 have to be looking at the same people. So, like, that's something we can kind of interpret from this. What if it's like 1, 2, 3, 4? Yeah, this is 6 people. What if we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 2 is looking at person 6. Otherwise 2 is person. Okay. So if A is strictly greater than B, really swap these values, and then B subtract A minus 1, then A essentially becomes 1. And N is going to be equal to, okay, well, if B okay, well, so we have this we can figure out how many people are in the circle. Because if it's 1, 2, if it's 1, 3, then we know there's 4 people. If it's 1, 4, then there's 6 people. If it goes 1 to 5, then there's 8 people. Okay, so int n is tentatively just, I guess it's just b minus 1. Yeah, b minus 1 times 2. If n is strictly less than max, we move on. Otherwise, we do if it's 1 and then 5, and this is something valid, then we know we have to just add it by that distance. And res is equal to c plus let's give it a shot. Okay, my A passed. Oh, problem C. Found a table having infinite number of rows and columns. They're numbered from 1, starting from leftmost. So it's a table. 1, 2, 3, 4, 5, 6, 7, 5, 6, 7, 8, 9, 10. Okay. He wants to know which cell will contain the number k. Help him find the indices of a row in the column such an intersection. Okay. There's almost 100 test cases. Let's see. Is that most? Like in the 30,000s, 300,000s, 3 million. I guess that's fine. I mean, we still will figure out the layer. This is 1 plus 3 plus 5 plus 7. Third layer is just times 9. Okay, so if it's greater than or equal to k, then L becomes layer, and then we get out of this loop. Okay, so now we know what layer it's in. We also know the length of a layer. So then it's like okay, so this is like the 10th, the 11th, number 10, 11, 12, 13. Okay, well, if L times L plus L int previous is equal to L minus 1 times L minus 1. Well, I guess long. Let me just is equal to 1. Okay. The previous, and then if previous, like number of blocks, plus L is strictly greater than K, then we know we know the column is we know the column is the lth column, and we know the row is the 1 plus, well, it's K minus previous. Otherwise, we know the row is going to be the lth row, long column. It starts from the lth row, and it's like minus, it's like K minus previous. Yeah. It's like K minus previous minus L. Oh wait, that's not right. 31623. Okay, 244. Okay, 14 isn't right. 14 should be. Oh wait, this, as this increases. Oh, okay, so long delta is equal to. Yeah, it's only as K increases, so it's like K minus previous plus L. Our column is equal to L minus delta. Yeah, let's try this. Okay, that's better. Problem D. I'm just gonna wait for it. Okay, well, we got B. And C is taking a long time to load. You're given an integer n in one move. You can do one of the following actions. You can erase any digit of a number, or we add one digit to the right. We note that after deleting some number, some digit, it could contain leading zeros. Leading zeros do not get deleted. Okay. If you delete from the number 301, the result is number 01. Perform the minimum number of actions to make a number any power of 2. And we cannot have leading zeros. Huh. So maybe we just loop over all powers of 2, and then for each power of 2, if our original number contains that power of 2 of a subsequence, we just have to erase digits. Otherwise, we just erase the digits, and then if we need to add more digits, then we add it to the right. Let's try that. So we have all right, we have n over here. Okay, we know that the upper bound on anything is to just delete all the digits and then turn it into 1. So This is an upper bound. Okay, so if that was 10 to the 9, then I know we want to do at most. What's 2 to the power 30? That's 1 million, right? Yeah. Okay. So you do this, and then okay, so the number of things we have to leave in. Okay, so we delete everything that's not created by the pointer. Array.length minus pointer. So this is after deleting everything. And then we add everything to where we just do something like this, I think. Okay, hold on. 1052. And for the first test case, let's consider it above. Yeah, because it's a subsequence of this. The target was 1024. So then it's 1024, it's 4 minus the pointer happened to be 3, so we got to keep 3 digits. So we have to remove 1 digit and then we add 1 digit. Uh, 1052. Pointer was 2. Wait. 1024, 1052. Pointer is equal to here. Oh wait, I'm stupid. Okay, let me just rewrite this. Okay, so this is the length of the longest subsequence that we can keep. And then we add in these digits, target.length. Two three one 231-302-13492. Why can it work for 2? Add one digit to the right or erase any digit of the number. Find the longest subsequence of this in here. That's what we keep. And then after we keep those, we just add digits to the right. Wait, how many digits is this? Let me just increase this to like, I don't know. I'll just increase it to 60. Maybe that'll help. Okay, that actually looks like it helped. Problem E. Polycarp is string S. You perform following actions until S is empty. T is initially empty. Okay. He adds to the right of string T the string S. Okay, so he does this. He selects an arbitrary letter and remove S from all of its occurrences. Okay. He adds to the right of string S. He selects an arbitrary letter. You need to restore the initial value of string S using only final value T and find the order removed letters from S, or determine if it doesn't exist. If S is equal to this, T becomes this, the letter B is selected, then S becomes this. letter A selected, then S becomes this. So letter C selected, then S becomes that. And keep on doing this until S is empty. Okay, well we can figure out what the last letter he removes is by just looking at this last part of a string. Like for example, in this case, we know that the last letter that remains is P. And then after that, we know that we can look at this over here. We know it says RPPP, which you know the next letter removes is R. And then we look at like over here, this is like a third letter, YPPR. And something like that. And then this A starts and then it's like PPR. Yeah, I guess it could be hard to determine when the character over here is contained or not. But we know the last letter removed is really easy to find. And then the second to last letter that's removed is also easy to find. And then the third, I guess we just go backwards to determine what order the letters were removed in, and then we just like check the string, for example. We know double P's are a thing. Well, the initial string starts off by, okay, so T does equal to initial string at some point. So we know how many letters existed in total. So here's some things that we know. We know number of letters initially in S. We also know the order characters were removed in S. We also know frequencies. So we can use frequencies to determine the initial S, and then just simulate process and check if it's valid. Okay, let's do this. So we just have okay. Two strings separated by spaces. The first one must contain. Okay. Let's let K be equal to frequency equals new int 26. For int x and frequency, if x is greater than 0. Okay, so this tells us how many distinct letters happened. We also know the order of the letters, as well as task and okay, so we mark this letter as seen, and then order.add at letter B. Okay, this is the order in which the letters are removed. So now we can use frequencies to determine what the letter was in the first place. Because we know that, just for example, if letter P start from I equals 0, the string itself can never be n. But I'll just consider it just in case. Yeah, because it's almost 26 times that, so it shouldn't be too long. It's like we could maintain a count order. Yeah, for multiple and solutions, print anything. Is it ever possible to have multiple solutions? I want to assume, maybe, I'm not sure. But a prefix is a possible starting value of s. If those frequencies like match up. So if we add a letter in, and that just gets disturbed. I'll just store all the candidates for now. Size. So we know that this is the first letter to be removed. So the buckets is equal to a plus 1. So if prefix, okay, well, if the total frequency of this is divisible by the prefix at C and frequency at C over prefix at C is equal to a plus 1, then it works. Otherwise, what's wrong with this? Works is equal to false. Oh, it's equal to 0. Okay, well, if it works, then candidates, we add i's -1, right? Yeah. Otherwise these process all these candidates. Wait, the first contains a possible value s, the second contains the sequence of letters that are removed, which we already have. Okay. I have an idea what I'm going to do over here. For int string s is equal to input dot substring from 0 to the prefix. What is 0 to the prefix plus 1, I guess. And so start at s and then for int remove, we do in order string builder long equals new string builder over here, and then for int I is equal to 0, I is less than s dot length. We know that if prefix at c is greater than 0, okay, s dot length I plus plus. If s dot char at I minus s does not equal to the one we're about to remove, then we append this. And then s becomes updated to this, and then temp.append s. Okay, and so if temp.toString dot equals the input, then we found a solution. Otherwise, we never found a solution if we exit this loop. Ugh, okay. In the order sp.append. Okay, let's give this a shot. sp.append. Oh, input dot substring from 0 to the prefix plus 1. Okay, and we're on to problem F. Okay, that's pretty fast. So F1 is a simplified version of, okay, it's just the constraints. Okay, I see. I'm given an integer n, find the minimal integer x such as k beautiful. Number is k beautiful if its decimal representation has no leading zeros, contains no more than k different digits. So the minimum k beautiful integer such that x is greater than or equal to n. Oh, I see. Yeah, in this case, we can just brute force the 2 digits that we use. I think for the hard version, we just use digit dp. So yeah, I can just do that real quick afterwards. Int n, int k. I mean, if k is equal to 1, we just... Okay. This is just the easy version. Okay, well, long res is equal to long.max value. Long temp is equal to 0. Or long temp is equal to d. While temp is less than n. Res equals min of res itself and then temp. Yeah, this is just like this version. If it's over here, then what we can do is we just brute force away the inner, like brute force. Equals 1, a less than equal to 9, a plus plus. Or b is equal to 1, b is less than 9, b plus plus. So as long as a doesn't equal to b, or wait, it's at most many. Oh, okay. So we always consider this case. It's just if k is equal to 2, then we do this part. So if a doesn't equal to b, then one thing we can do is we can just if it contains, okay, if our number is all 9s, then we just output it, then we just output itself. And then it would have been covered over here anyway. And res is strictly greater than n. Because if it's equal, then that's the best possible answer. Okay. Okay, so a is the first digit that we use. And a is, let's just say at least as big. I mean, it might be better to just do the digit dp, honestly. I think I'll just straight up do the digit dp. Yeah, I mean, I think doing digit dp outright is okay. Just curious, how are my friends doing? Okay. Cool. K is equal to, and then we do digit dp. I guess if k is at least 2, so what would the digit dp look like? It would just be like dp at if we're constructing a value, we start at the largest digit, yeah. So it's like int. So the first parameter is which digit we're on. The next parameter is whether we've exceeded the overall value or not. And then the third thing is the mask of things. So dp is equal to new int Okay, so it's M, 2, and then it's a mask of at most 10 digits, so it's at most 1000. Okay. This is going to run in about that much time. Yeah, that's probably okay. So then it's just dp at we have integer. I'll use a long. I mean, 10 to the power 9 is at most a k-digit integer. Yeah, we can actually fit everything in integers. dp at I and then b with infinity. Is it in the starting? So the starting digit is going to be array at 0 minus, this is a numeric value, plus 1. Yeah, so the lowest possible value we can do is dp at 0. 1 means we've already guaranteed exceeded the initial value. And then over here, it's just like it's equal to D. And then if we start at this digit itself, then we know that it starts at 0. Is equal to this. For int I is equal to int. Okay, so we look at each transition for int. We consider the digit that we're about to add, I guess, right? And for int if it's less than or equal to k, then dp at m minus 1 at 0 at mass. Yeah, and it's a min of this Yeah, so last thing, mass just shows the digits that we used. Yeah. And so for each, I guess for each digit that we process, the only thing that we care about is the previous mask. So this is like 9,000, like 18,000, 20,000 maybe. Does this run in time? I mean, it might be kind of tight, but... $1,000 times 1,000 times 10, 10,000. Maybe that's actually a bit tight then. Because 2 to the power of 10 is 1,000. I guess we could remove a lot of states if... Yeah, we can remove a lot of states if k is somewhat small. So it's like... If we know which digits we've used. Well, we still look at the starting digits. It's easy to make it, although we only have almost 9 digits. Yeah. And then it's really easy if we make it almost 8 digits, right? Because it's at most 10 to the 9, right? There's at most 9 digits. If you want to make it so that we have at most, like, I don't know, 10 to the 9 meaning, like even something like 1, 2, 3, 4, 5, 6. Yeah, even that would like never exceed it. So it's easy to make it have only two different digits. It's the most, like in here. If these used to be different, we can make a few of the same by like combining it over here and then here. Okay, I think I have a way to optimize this where if k is at least as big as 8, then we can just brute force. And then over here we know k is less than 8, then we only care about masks that have 8 or fewer subsets. So it's basically like 10, choose 7 or less. And that should be pretty small, I think. Or like it's smaller by a constant factor. Right, because if we increase this by like about a few thousand-ish, then we can just say that the number itself isn't much bigger to begin with. Oh, you know what would be better? What if we just like noticed that for example in here, these first few digits stay the same. Oh, right. And then we just find the smallest number that we can force using those digits. Yeah, that's actually a lot better. Okay. I'm gonna make another file. Yeah, because I think digit DP is like, it's like, they make constraints tight enough to where I'm pretty sure it won't run in time. But I think what we can do instead is, we basically have a mask to do this. So if this is something we haven't seen before, if it's already equal to k, then we have to break. Otherwise, we go ahead and add it in. So we have a collection of digits that we can use. Head is equal to -1, then it's always possible to just keep its own number. Ow. Yeah, otherwise we have like a smaller number, right? And we just want to figure out what is the smallest number we can make using these digits such that it's at least as big or bigger. So it's like, Okay, well, if k is equal to 1, then we can just do this part over here. Otherwise, we can assume there's always at least 2 different digits. If there's 2 different digits, then it's possible that these last digits are bigger. So what happens then? Maybe we still need digit DP. Maybe not. And it's like if we do something like here and then here. Wait, okay, we have some collection of digits and then like some other digits over here. If our largest digit in here is larger than x, and we want to get the smallest digit such that that happens. Let me increase it by that. If that doesn't work, then we can actually backtrack a little bit. And then just say like, something like this. Okay. And it's not possible to just break. Let me go ahead and process. Okay, otherwise we have some set of digits starting at index I plus 1. Okay, so if we've seen this digit before, since this is the largest digit that we've seen, if the largest is, well, int pointer is equal to, I guess I plus 1. If it's like this, then we can say a is equal to 0, a is less than or equal to I, a plus plus, where temp at a is basically just array at a. While pointer is less than m, I think. If largest is it's like we're about to process this digit. So if the largest digit is strictly greater than array at pointer, else if largest is equal to this, then temp at pointer plus plus is going to be equal to temp at 0 is equal to array at pointer. Else, then largest is less than that. And then we just continue outer. Okay, if it's larger, then we do this and we force them greedy, otherwise long. Temp. So we do this, and then we multiply it by 10. Okay, if largest is strictly greater than this, then okay, so if mask has seen this digit before, and dd is strictly greater than array at pointer minus this, then we know that temp at pointer is going to be equal to this, and then we break. And then for int a is equal to, we already established pointer. And so we do pointer plus 1 while a is less than m, a plus plus, we do int smallest is equal to so if mask and one left if the ed and then temp at a becomes the smallest plus this. And then we just break out of here. Let's try this out. Okay, something's not right. The 17789. Oh, okay. Yeah, maybe that part isn't how you do it. Maybe not. But these are all somewhat valid. Wait, 3, 4, 5, 8. How am I getting 3, 4, 5, 8, 2? What? Why is that happening? Three, 4, 5, 1, 2. 3, 4, 5, 1, 2, and 3. Wait, 3, 4, 5. Wait, shouldn't it be 3, 4, 5, 3, 3? Like, why is this happening? If I is equal to 2, yeah, it should be 3. So why is it giving this? If I is equal to 2, oh, 0. Okay. Okay, that value looks a little better. I don't think it's correct yet. Like 177. Yeah, res is equal to n, then we break. Not if it's like all 9s. So if let me just move on. Otherwise, in this case, we could like increase its digit by 2 and then make these as small as possible. So it's like we do 2 and then okay, the only thing that we save in here is array and then basically just array and then m, and then we can reuse mask. So mask is equal or equal to 1 left of that array at head minus this integer.bit count. We increase the digit while keeping the previous digits the same. we do this part and then so we do this. If array at head does not equal to, or wait, if array at head plus add is less than or equal to 9, then we can do this part over here plus add. Yeah. Then we have to continue. Okay, if mask is less than, if it's strictly less than k, then we can just have smallest be equal to 0. Else, smallest is just the smallest bit in here. Okay, so we do this part, and then we go ahead and just fill everything out in here. Where I is equal to head, it's just equal to smallest, right? So then it's just temp at I is equal to smallest plus this. Maybe. Okay, let's try this. Nope, still not right. But why? Well, if add is equal to 1 and head is equal to 1, okay, we do this over here. Oh, I'm gonna do the second sample. Oh my god, why is that happening? Wait a minute. Oh. Okay, I was just being stupid. I want to be very surprised if this is correct, honestly. It's so sketchy. Yeah, I what a surprise. Do we think it works for this though? I want to try. I feel like it's possible that it works for this case. If it doesn't, then oh well. Nope, not even that. Okay. Okay, so what's happening here? K equals 1 should always be right, so K equals 2 is when it's not right. Let's like just do like some random numbers maybe. Oh wait, what? Oh. We have to end it with a 2 and then end it with a 2. 3, 5, 3, 3, 3, 3, 4. Okay, that's not right. Wait, that's not even. How did that even happen? Wait, it's literally less than this. How's that even happening? What's our current res equal to? How did that even happen? What? I wonder what happens if I just get rid of all this. Like I just eliminate everything in here. That looks like it could be correct. Oh wait, what? Wrong answer, test case 1. 1, 2, 2, 2. Oh, 2, 2, 1. Integer.bit count overall is less than or equal to k, then res can just be equal to n. Okay, we got F. That was so. Okay, honestly, that shouldn't have been as hard. This wasn't as hard as. I definitely should have spent less time on it. I just got caught up like thinking about the DP. But yeah, we're done. Okay. I don't know how to feel about this contest. It was very weird, honestly. Like especially this like this greedy. Yeah, it was just greedy. Yeah, overall pretty boring problems. I don't know. Should I think of? I think the problems there were. Okay, which problems did I like? Problem E was kind of interesting, I guess. Like just figuring out like what condition do you need to make. You need to like observe such that you can retrieve the original string. Maybe that's fine. D I guess is interesting for div3. I don't know. And then F1, F2 are just annoying. But yeah. Aside from that, that's my contest. Hopefully you had fun. I might make solution videos later today. It depends on how busy / tired / productive I feel. But yeah, see you then.